Hello and welcome to a new section. In this section, we dive deeper and learn how to write our own Arduino libraries. This is a useful skill if you want to contribute to open source libraries, work on large, more complex projects, organize your code in a better way, or deliver your work as a modular package. In this section, we shall use OOP, Object-Oriented Programming, concepts in C++, and learn techniques to perform a number-based conversion in a modular way. So let's get started with the first video lecture of this section. We build on the ideas of the number-based conversion which we had started at the end of the previous section. In order to convert from decimal to hexadecimal numbering system, we introduce a very common standard C method, sprintf. This method takes two arguments. The first argument is a string buffer where the result will be output. The notation here, character asterisk, denotes a character pointer. Pointers are a very tricky concept in C and C++, but in a simple way, it is a variable containing the starting address, a memory location of another variable. For example, when we say character pointer, that should be the address of the first letter of a word. The second parameter here is decorated as a constant character pointer, meaning that it will not be modified by sprintf internally. This variable is the formatting we would like to use for the string output. In other words, we may like to print some constant words followed by some variable values, and then by some more constant values and so on. We should elaborate more on this concept in the coding tutorial. Finally, we see three dots indicating multiple arguments, which stand for the actual values that will be used to replace the placeholders in the format string. Sprintf returns the total number of characters written on success and a negative value on failure. Let's make it clear by getting our hands dirty. Let's start with an empty sketch, and instead of writing our code directly inside setup or loop, we will define a method to wrap the functionality in a modular way. The return type of the method should be a string. We name the method decimal to hexadecimal. And since our data is coming from sensors, could be both positive or negative, and to make things interesting, let's assume they are of type long. So we say signed long and some value. This will be the input to the method. Now let's define the buffer. We start by specifying the buffer size to be constant, integer 8 underscore t, and note here that integer 8 underscore t is the data type defined by Arduino API to signify an 8-bit integer in contrast to the regular 4-byte integers in C++. And let's name it size, and we make it equal to 8. So in this conversion, we are using a buffer of 8 characters. Now let's define the actual character array by typing char. We name the variable buff, and then we specify the size which we have just created, and semicolon. And now let's use sprintf to do the magic. Sprintf, and we pass the buffer for the output, and then the string format. And note here the formatting, the placeholder starts with a percentage sign, and then we specify the type of the value that will be located in this placeholder. Here we are converting from decimal to hexadecimal, so we denote that by x. So x stands for hexadecimal, and that's our string. And we could type as many words as we like, and we put as many placeholders as we can, but we'll use one placeholder in this example. You can play around with the code and try more placeholders and more types, and you'll find always in the attachments of the video lecture reference to the C++ documentation so that you can know the notation for other types and how to use them with other placeholders. And now we have specified one placeholder, and we pass the value that will be used for the replacement in the third argument. If there is another value, we add more values in this place. And finally, let's return the newly created character array or string. we type down return buff, and that should be it. Now let's call this method from inside setup. As usual, serial.begin 9600, and then we create a variable. We name it str of type string, and then it should hold the value returned from the method we have just created, decimal to hexadecimal. And we pass the value 134 to be converted, semicolon. Finally, we print the return string, serial.println string. And let's save by typing Ctrl S. And let's upload the code. Now that it has been uploaded, let's open the serial monitor. And here we've got the same value I've got from the previous lecture, 86, which stands for the hexadecimal value after converting 134 or 134. One more note here on the string class of Arduino API. We can see here how we converted seamlessly between the character pointer or the character array and the string type, meaning that the casting was implicit and we didn't have to do explicit type casting for these types. That means Arduino is compatible with the basic types of C language and C++ language, since the Arduino language is a wrapper above the C++ language after removing some of the unused libraries and that library that were not going to be useful in the microcontroller environment, which is very restricted. Thank you and see you in the next lecture.